you all get my feedback email? Is that good? Okay. Did it ask you if you wanted to schedule?
Yes.
Okay. Alright, so fill that out if you want to talk. And then I also might send some of you individually some of the schedule requests too. So, look for that, I guess, in the next day or so. Let's see. Alright, to just for like some of the feedback, thanks for filling that out. And based on our feedback, we got more fruit snacks. I guess also, since we've had a couple people ask for it, I'm gonna go ahead and you should start seeing the notes for tomorrow come out a little bit earlier, so I have it published at like 4 o'clock. So even today, tomorrow's stuff should come out. So if you want to review that, feel free to review that. If you go ahead, just be polite and don't hold your questions if you have questions on stuff that we're not haven't got to. Or maybe after the question for the day, so just be respectful. Other people if you're fortunate to get it. Let them get their question in first before you ask questions on stuff that you're ahead on. So, alright. Any questions about databases from yesterday? I think everyone seems to be doing okay with that so far. Yeah. Alright, let's see if this works. Alright, so today we're going to be talking about relationships in our databases. So let's get that going. Alright, so make sure you got your little elephant running up here. If you're going to try any of this out, make sure you have your database going here. So anytime when we're talking about relationships, we're talking about different. These all translate to tables in our database. So think of the data you're trying to describe and the tables that would correspond with those. So, we did the blog, right? So you might have authors, and you might have, they have written certain articles. That's a relationship. Cars and owners. A car has maybe one owner at a time. But an owner can have multiple cars, right? Parent, children, these are just a couple of examples. So today in our exercise, we're going to go through some of these and create databases out of them. And we talked about this before. There's basically only like 2 types of relationships. There's a one-to-many. So, a blog post, right? A blog can have many posts. And then there's also a many-to-many. So, we did a category for our polls. Poll can be in several categories, and categories can have several polls. We talked about some of the other relationships, like the self-relationship and the one-to-one. That's just the one-to-many with some constraints on it. So, but basically it's just still a one-to-many relationship. So you got to think about your data and your site that you're building, or your app that you're building. Think about, can this thing has multiple of its other things, or the other way around. So this is the kind of questions you want to ask yourself when you're building and structuring data. Another question might be, how do you want to extract this data? And so that maybe you don't want to write this really long query all the time. How do you want to use it? How do you want to take that data out? What query are you doing more often? So if you're doing a query on 10 different pages, and then you're doing another query on one page, maybe you want to optimize for those 10 times and not just that one thing, right? So sometimes you'll have to pick. You can create a relationship, and you want to make it easy for yourself. Most of the time, it's maybe going to be hard a little bit of the time, right? So sometimes too, your data is just based on how you can get it, not necessarily a real world relationship, right? So that's the kind of compromise you have to make when you're designing your data. So let's take a couple of examples here. So, author and article, right? An article can have an author, right? But you maybe also want an author to have a list of articles. So, on our website, on our blog, right? Most of the time our main page is showing the blog page, right? So maybe it's easier for that relationship to go from article to author instead of the other way around. Eventually, maybe when your site gets bigger, you want to start listing out your authors and all the articles they've written. But the main thing of the site, right, is reading some content. So let's optimize that query first. Optimize around that. Another example, right? A team and a member. So, maybe that's like a many-to-many relationship because you can be part of more than one team. So, think about your data and think about what kind of relationship you should have. All right, so let's actually do one of these. So you can see in this one, before I start trying it out, I'm going to make an author table, and I'm going to make an article table. And I've decided, like I said, in our blog, right, our main purpose of the blog is to display some content. So I could model this by doing like a many-to-many, but I'm going to model it like this way, one-to-one, because most of the time, I only really care that an author has one article, and I'm usually displaying articles most of the time. So I'm just going to make it a one-to-many. Now, when my site gets bigger, or when I get more editors or something, maybe I can have articles that have more than one author. So then I would use a many-to-many relationship. So, there's not just like one good answer for this a lot of times. So this is where you're never going to get the right answer up front, like totally the right answer. So don't try to pre-optimize too much. If posting an article and having one author is all you're going to do, it's a good place to start. Just do it. You may never get to that point where you actually get or meet that feature, and then that's going to slow you down. And we'll get to the performance trade-offs. So if you do a many-to-many, right, that's slower than just a one. So we'll talk about that here in a second. Anyway, you can see in our article table, we have at the bottom, we have an author ID field. It's going to be an integer, and it references the author table and it references the ID. So remember, always, 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 you want a primary key and you want an ID. 99% of the time. It will make building your relationships a lot easier and keeping your data consistent a lot easier. So, 99% of the time, always do an ID as your primary key.
What reference does it have to be for a primary key?
Yes, the reference you usually want, again, 99% of the time, you want it to reference your primary key. That will give you better performance and also keep your data consistent.
So could you reference others separate?
I don't know if you can reference others. It definitely has to be a unique field. It can't just be any field, it has to at least be unique. But I'm not sure, actually I'm not certain it has to be a primary key, it definitely has to be unique. But you almost, 99% of the time, always want to reference the primary key. So just put an ID on it. Just do it. Alright, so let me try this out here. Alright, I'm going to go into my test database. I'm going to create a table. Author. And we're going to name it ID. Feel free, if you don't want to type this out, just copy and paste this and put it into your poster code too. Maybe I'll do that for the second one. So you can see that. Let's try it out. Alright, then I'm going to make a name as a bar card. Alright, so now I have an author table. So remember, this actually will be a lot easier for if you make errors, if you come in here and do it in Costa Code. So remember, you can come in here and do things too. And make this font bigger now. So for the second one, just to kind of show it off, I'll put it in here. Create table. Article ID is serial. Primary key. And that's going to have a title. So you can see that last line, the references keyword is what tells it to reference another table. And so I'm saying reference the author table and reference it by the ID field. So then if you're in Costa Code, you just get an execute statement. And if you get an error, right, it makes it real nice because I can just come in here and fix it and execute it. So one word on kind of naming things. You can name that author ID field anything you want. But normally, that's kind of the structure that you want to follow. You want to name it the same name as the table that you're referring to, and then an underscore, and then the name of the field that you're referring to. So that will let people know that, hey, this is something coming from the author table, a relationship with the author table. So you can see that really quick without having to look at your database statements. Alright, so if you look in Costa Code, now if we go back here, do a refresh. You can see I have an article and I have an author table. Any questions on that? Yeah, structure code highlighting, it usually is very helpful, but sometimes it's not. Alright, so let's go ahead, and I'm going to go ahead and put some data in here so that we can actually make some queries now. Now, you could use the insert statements, but if you come in here and post a code, right, you know, it's just real nice. I thought they had like a selector. It's not. So, you know, it makes it a little bit nicer to just fill out some data real quick. You can get it. You can hit that little icon, and it'll let you pick. So this is an anonymous article. And I'll do one more for myself. Alright, so I put in 5 different articles. Most of them have an author, and I have one that's by anonymous. Alright, so just to kind of review what we did yesterday, right? We want to pull out, let's say, all of our articles, right? We can pull out all of our data from our articles and get that back. And then we can also pull out all of our data from our authors. Right? So there's all of our. Alright. So now, this is where these relationships come in handy. So now we can do what's called a join. So, you know, when you want to publish this article to your site, right? You probably want to pull out an article, but then you want to also get the author information, put that on the page too, right? So we can do 2 things. We can either do 2 queries, pull off article, and then pull out the author for that article, or we can do what's called a join. So if we do a join, we can get it all in one query all at once. So let's try this out. We'll try out that first one. Alright, select star from article and author where alright, so now this is kind of like our Python code, right? On every article we have an author ID field, so we can do article want that to be equal to our author.id on the author data. So now what will happen is it's going to pull everything together for us. And we're going to get one query that shows all of our data combined. Let's see what happens. So now you can see we get one table. We have our article data, and then we have our author data, and it's all combined for us. So let's talk a little bit about performance. Anytime you do a join, that takes CPU power and memory up. It's probably less CPU power and memory than having two queries. So if you have a choice between a lot of queries and a join is probably better. But the more relationships and the more joins we do, it's going to take up more resources. So at some point, when your data gets really big, that's when you might want to denormalize stuff and repeat data instead. But for consistency, if we split things up and don't repeat our data, it really helps keep our code cleaner and we have to code less. But joins do come at some performance cost. So like one join like this, not too big. Two joins, it's starting to get worse. Three joins, it's going to start taking more CPU and more memory to follow all these relationships across our data. Alright, so let's do the second one. The second one is actually the same thing. So let's see what happened, but it's just a little bit different syntax. So let's try that. So now we get our data and we get that join. So when we did the first one, we didn't specify it, but what we were doing is an inner join. So an inner join is like the default. But what happens when you do an inner join? We're going to do an outer join here in a second. You got a question?
Yeah, it should be good.
So the if you look at our table here, what's missing from our table? Did we get all of our articles back? Yeah, so we're missing the one that didn't have any author. So maybe that's what you want. Maybe you only want articles with authors. But maybe we want this list to join the authors, but also include stuff that's anonymous. So with the inner join, it only gives you the data that's been joined. If we want to do something that gives us that data, plus the data that doesn't have a join, we got to do a different kind of join. So when you do the default join, which is the inner join, it only gives you the rows that have been connected. Sometimes you want to do an outer join to get the rows not only that have the relationships, but the rows that don't have relationships. And I think that's the next one. Alright. So this is the outer join. And there's actually different kinds of joins. So let's go through these and see if you guys can see the difference between the data. So let's do this first one. Alright, so this first one I'm going to do what's called a left outer join.
article.author ID is equals.
Alright, so you can see when we do this left outer join, right? Now we get all of our articles, we get the ones that have a relationship, but we also get the ones that don't have a relationship. So we still get a full list of articles. So for our blog posts, this is probably what we want to do. When we list all of our pages, right? We might have some pages that don't have any authors. So this is probably what we want, for a blog site. We still want them to show up in the list. Alright, so let's try the other way. So you can do the exact same thing here, but just change it to right outer join. So what happened here? We did an outer join, but we're missing our article that doesn't have an author. So the left and the right, the only difference is which way it joins from. So with the left join, we went from article and then joined to author, right? With the right join, we're going the other way. We're going from author to article. So since that article didn't have any authors, we won't get this. So you can pick which way you want to join from. You can also just switch your query up. We could just switch this to do select from author and then do a join that. So let's try that out. I don't have it on there. But what if we did it this way? So instead of author, instead of article, we put author there, and then we join on article. So you can see that gives us the same query. We just kind of flip things around. So the left and the right just tells the database which direction to make the join. Any questions on that?
When you alter the ID, would you add all the columns? Because the other thing is
Yeah, so add more columns. Well, we're right now we're doing star. So you're saying to author add more columns. Do you want to select that data or?
so you come every start.
Yeah, so if we do star, so I didn't show this off, but if you want to, let's say you want to select some things. So we just want the article title. So now you can also select and then we want the author name instead. Like that. Exactly. Great. So now you can select the fields, first table dot, second table dot. Alright, so let's do this last one. So there's one more kind of join that we can do. And this is a full outer join. So who can guess what they think this one's going to do? Basically, it's going to do both ways at once. Let's see. Go back to this original one. So you can see I do a full outer join. And my data is kind of simple, but a lot of times when you do the full outer join, you'll get duplicated data for those relationships that go both ways. So just be careful. If this actually looks at the left and the right, it joins both ways. because our data is kind of simple, we're basically getting the same thing as the left outer. And, you know, honestly, like the left outer join and the inner join are the ones usually that use 95% of the time. But I just want you to make sure you know that there's these other tools out there that you can use too. But normally, you know, the inner join and then the left outer join are the ones that we use to pull out. Any questions on joining? Alright, so let's do a little bit I guess more complex work. So this next one, let's look at it here. We're going to select the author ID, author name, do a count on the article ID, and then we're going to select our articles, do a join, and then do by author ID. So what this will do is give us a count of the author and their ID and how many articles. Let's try it out. So we're going to do the author name and ID. And actually, I didn't follow my own advice. I should have a capital count. So we got my authors, and then I have a count now of how many articles each of them has done. Now, this is starting to get more expensive because not only are we doing a join, but we're also going through the whole table and counting how many articles each author has, right? So this is where your database queries start getting expensive. You gotta think about, you know, do I denormalize the data? So, you know, if this was like, if this was information you need to constantly get at, you know, you always want to keep a tally of how many articles an author has. Maybe that's a field that you want to have on the author table that gets calculated maybe like every day for you or something. You know, this starts getting really expensive because if your table gets busy, you now have to load the whole table in the memory, count how many articles that guy has. So, you know, be careful. When it's small, you know, you don't have to worry about it. But when you start running into performance problems, now you might want to start thinking about restructuring your data. It's just random order right now. So, unless we give it an order, it's just going to be depending on like how it's saved or it's going to come out. So it's kind of like a dictionary. You know, you can put stuff into the Python dictionary, but you never know when you look over it, how it's going to come out, unless you tell it how it works. Again, that's a good question though too. The question was which order. Right now it's just random. Now if we add an order by, because we want to come back in a particular order, now that's going to make it expensive too, because now it's got to take all that data and reorder it. So if you don't need a particular order, right, don't use the order by unless you really need it. And these operations, you know, the database will handle a lot of stuff for you. Don't try to optimize that first, but when you run into problems, you can slow through. say count is the total. See if I can get this right on the fly here. And then I'm gonna say order by total. So now let's say I want the top, the people with the most. There we go. Put descending on it. So now I have the people who wrote the most at the top. Again, right now our data is small, doesn't matter. As our data grows, ordering all these things is going to become more and more expensive. Any questions on the article count? Well, so you gotta think about your math, right? And you gotta think about, are you going to sort, how many authors do you have? Because if you only have 100 authors, that's actually not a lot. Like, you can sort stuff in databases, and you're not probably gonna hit like a problem until you get to like a million. So, if you're sorting authors, and you only have like 50, probably not gonna hit. But now if you're sorting articles, and let's say you have like 1 million articles, now you gotta think about, like, okay, how am I gonna do that?
Yeah, you might want to go to sort of
Well, so, we won't really get into this, but what you do is put an index on your, so say you wanna sort them by date, put an index on your date field, and now you can sort by date faster.
just the index and stuff like that.
So an index basically, right now, we have data fields, right? Anything that you index, the database can look up it. So it's like a dictionary, it has a pointer to it. So if there's something that you're searching a lot for, or working a lot for, you can index it. And then your database is able to pull it out. Now the downside of that is that now you not only have to write the data when you add something, you also have to build an index. So you get slower write performance so that you can read it. So yeah, anytime you want to speed up a certain data field, you can put an index on it so that you can read it. But then you have the write performance, it's going to be slower to write. Right now in class and for your projects, you probably won't have like a lot of data, so it's not going to be a big problem. Yeah, you can add. Yeah, so what you would do is you would put that index on one. Whichever one you're doing the searching on. So we actually have one index on all of our tables that we've done so far. Can you guess which one? Anytime you make a primary key, it's actually indexed. So it's assumed that you want an index. So anytime we make a primary key, when we have that's why the relationships are so fast, because they get indexed. But you can go in and add an index on any field. Anything you search or sort by, you can put an index on it. But wait until you hit that problem, because you're going to make your writes a lot slower. You make your read faster until you make your write slower.
You can add that. No issue.
What's that?
You can add.
Yeah. So you'll have, the only issue is that there's a lot of data. When you go to build that index the first time, you might have some hand. But once it's built, you can add it in real easy. Alright, so let's talk about a many-to-many. And we kind of got this for free with Django, but this is actually a lot more complicated. So we're going to build this actually works in our database. So we're gonna have our team, and then we're gonna have our member, right? So the way this works, because you want your team to have multiple members, but you also want your members to have multiple teams, is we actually have a database table in the middle that connects the two. So this is how you build a many-to-many relationship. Now, because of that, anytime you want to pull out, you know, a team and then a member all at the same time, we now have two joins. So this is a much more expensive table than just a one-to-many table. So you got to be careful with these. You know, only use them when you need them. All right, so let's try this out. So let's go ahead and build the team table. And again, I'm going to do a primary key ID. Alright, so there's my key table. And here's my member table. Alright, so before I do this last one here, I like to follow the naming convention. So this middle table that connects the two, I like to follow the naming convention of having both tables in the name. So I'm having team underscore member. In the exercise, I think for today they asked you what that might be called. So what would be like more like a real life name for that? You have a team and a member. What would the thing in the middle maybe called? Organization maybe? Anyone else have a? So maybe like, was that membership? So some people like to call this membership. So I kind of like to keep it so that I know which is which. But a good alternative name might be a membership name. I like the name to kind of show me what's connected to the data. So that's just different styles. So I'm going to call it team underscore member. So now, all of this, you can see all of this middle table, this team member table, all of this is a team ID and a member ID. So all it's doing is connecting one table to the other. But again, we want our own primary key for this table. So we're putting a primary key on the table. So I'm doing a team ID. And that references my team. And then I'm doing a member ID. And that references the member page. Alright, now if you got this right, you can come back here in postal code and refresh. about that too, right? This is more data, more code. So many amenities are just harder because we're doing more stuff. Alright, so I put in some teams. I'm going to put in some members now. Some teams, I got some members. Now if I want to connect the two, I have to come into this team member table. So I have it right here. So now I can say, okay, in team one, I'm gonna have Paul, and then, or I can think about it the opposite way, right? I can think about it as Jill being in team two. So the relationship goes both ways. I'll put in a couple of these. So team one, I also want team one to have Jill in it also. And then I'll have team four. So I got some data filled out. Any questions before I start ordering this data and pulling it out?
There's that. Good to see all y'all.
Alright, so that means since Max is here, we got to put Max in. Alright, so I do one more. Alright, so what was your question? So basically, you have to form team in each table. You could, but then a member would only have one team, right? This way, a team or a member can have multiple teams. Exactly. Now I can have put Max in team two. Yeah. So now, right? Team one can have multiple members in it, but also a member can also have multiple teams. Alright, so we got some data. Alright, so let's make a query now. So you can see, remember our default join is an inner join. So you can see now instead of having to do, probably pull out that whole relationship, instead of doing one join, I now have to do two joins. And you can see where this is going to get super annoying, right? It's like a lot more bigger queries. So every time we add a relationship this way, right? The queries become more and more complex. So they're going to have more and more code to pull this stuff out. So let's try that out. Alright, so I'm pulling from the member table. ID. And then I'm gonna do a join on team, get the team out. And again, I'm joining on team member, team ID equals team ID. So now, since I joined on member, right? Again, going through my member table, and then I'm seeing which team they're on. And you can see, right, Jill was on multiple teams, so she is joined multiple times because she was on team 1, but she's also on team 2. So I get multiple data on her. Any questions on that? Alright, let's go on to the next one. Oh, so that's all I had for right now. We're going to do some more advanced queries, but let's just talk about if I were to do the outer join or left and right join, right? I'm going to use different data back. So let's just try that out real quick. But you can see this is going to get more and more complex because I have 2 joins to pick from. So do I do 2 outer joins and 1 inner join? You know, this is the stuff that gets like really confusing really fast. So I'm just going to, and a lot of times, it's even hard for like me doing this, right? So I just experiment and see, you know, go into like a post-it note or some tool. I know what data I want out, but sometimes it's hard to like think about the actual query that I should make. So I guess I need to do it to the left. So now you can see when I do the outer join, I get Joan here, who isn't in any team. So you all need to pick her for your group project. So, you know, part of this too, you can get really complex queries. Part of this is, you know, making sure you design your data so that the queries you want to use most often are simpler. You know, so that's part of the database design too. Don't shoot yourself in the foot. Right? There's a query or a type of query that you want to pull out more than other types. And you might want to design your data around that. Alright, well if you have any questions, we'll take a break for like 15 minutes here and we'll go into the last part of this.